Good morning, everybody. I hope you're well. Good morning or good evening, depending on where you are. We've got quite a big audience tonight, or this morning, or the middle of the afternoon, depending on where you are. Listen, on behalf of Iconic Translations, thank you very much for attending our first session of the day, which is MT 101. You can see the agenda of what we've been running over the last couple of days. This is to coincide with Legal Week, and we hope that you find our input to the proceedings helpful. You obviously, some of you, by the looks of things, have already attended some of our previous sessions. This one's a little bit different, and we'll be repeating it again later on at 7 o'clock UK time. I'm not going to say too much more other than I would implore you, please, to ask questions in the questions box. We will do our level best to get round to all of the questions at the end of the session, if we have time. If we don't, then please tune into our live Q&A at 3 o'clock London time, Dublin time later on today, where we'll take all of those questions and I'll be posing them to John and putting my boss on the spot to see how that goes. Anyway, without further ado, let me hand you over to the man, the legend that is Dr. John Tinsley.
Thank you, Stephen. So thanks for joining, folks. So yeah, this is a little bit different than the sessions we had earlier on in the week, which were kind of more product demo focused. This is a little bit different, hopefully a little bit more fun. Basically going to give you an overview of machine translation, how it came to be, how it's evolved, and a little bit about how it works. It's very first principles. So the assumption here is you're aware of its existence, but you don't really have much of an idea how it works. So I'm going to explain that a little bit about its evolution, and so hopefully what you'll take home from this is, okay, you understand a little bit about how it came to be, why it's good, why it's a hard thing to develop software for, and so on and so forth. By brief way of overview, I mean, Stephen would have covered this in the previous talks, just about Iconic ourselves. Machine translation is what we do, and we work with corporations, law firms, and service providers to provide them machine translation solutions in different guises. Obviously, we're running this seminar series in conjunction with Legal Week, because a lot of what we do is providing solutions for the legal sector in terms of litigation, compliance, e-discovery, and more. So machine translation is what we do as Iconic. Personally speaking, it's my own background as well. I've been working with machine translation in education and professionally since 2002, and I co-founded Iconic Translation Machines as well. So it's pretty much all I know how to do, and all I have done for the last couple of decades. So I like to think I know a tiny bit about it. So I'm going to go right back to the very start and tell you a little bit about how machine translation came to be, and then get into a little bit more detail. But don't worry, it won't be anything too scary or mathematical, which is what the reality of the situation is. So this is how machine translation came to be. And we say it's a young technology, but all technology is relatively young. The concept originated in the 40s, and the first implementations happened in the 50s, actually as a collaboration between Georgetown University in the US and IBM, and they were developing Russian to English machine translation funded by the US government. So you can take any guess as to why that was of interest to the US government. And the approach that they used there was what is known today as rule-based machine translation. So effectively writing rules, in that case, to convert Russian grammar structures into English grammar structures, and using dictionaries to actually translate the words. So that was the first kind of instance of machine translation. That went on for a while, and then in the 60s there was a report published called ALPAC. Sorry, at that time, and they said the machine translation problem should be solved in about 3 to 5 years. And so maybe 10 years later, this ALPAC report was published that said, this is a lot of rubbish. All the money we've invested in it has been wasted. Stop funding these idiots. And so machine translation sat in the doldrums for about 20 years, until in the 80s, funded kind of by early European Union, European Commission money, there was a successful machine translation project called Meteo, which translated weather forecasts. And the reason that was partly successful was because weather forecasts are generally easy to translate, right? There's only so many ways you can describe the weather, even if you're based in Ireland like me. And so that's kind of what got the ball rolling again, and research picked up, and a number of groups were established in Europe. And then in the late 80s, early 90s, we had our first paradigm shift from rule-based machine translation to what is known as statistical machine translation. And again, that was spearheaded by researchers at IBM. And that was effectively moving away from the idea of rules and grammars to what we would call today machine learning, statistics, counting, to solve the problem of translation. And in the early days, that focused on statistics to translate word for word. As it evolved in the red, it moved from translating word by word to phrase by phrase. And then after that, it moved from phrase to phrase to looking at more kind of linguistic information. And so, that's where I got started in machine translation in 2002. And it evolved like that for a while, but it kind of plateaued. What researchers were working on by the end was very kind of niche things. For example, you'd have PhD theses on how to translate German nouns effectively. So it became quite niche. But then in kind of 2016, 17, we had our next paradigm shift to where we are today, which is called neural machine translation. And that's effectively the application of artificial intelligence to the process of machine translation. Now, the interesting thing is these algorithms aren't new. The AI concepts and algorithms have been around for a while, but what caught up is actually the compute power that is needed to actually churn through all of these algorithms. And neural machine translation has evolved very quickly over the last number of years. And if you are a user of machine translation, you will undoubtedly have seen it improve. And this is why. And so I'll talk a little bit about that later on. But let's jump into a little bit of meat about how neural machine translation works. So what you see here is effectively an encoder-decoder architecture. And I'm joking, I'm not going to go into the details of that. I'm going to go way back and talk about some of the very high-level context. So like anything in machine learning, artificial intelligence, machine translation works by learning from things it's seen before, same way as humans do it as well. So what we do is we basically train machine translation systems on previous translations, and it learns from them and uses that learning to produce new translations. So on the left-hand side here, if we give an example, if you show a machine, so if we look at English, Spanish is the language combination we're looking at here. If we tell the machine that the word dog translates to perro in Spanish, and I have a cat translates as tengo un gato. So that's what it's learned. It knows how to translate dog and I have a cat. Then theoretically, we can say, hey, machine translation, translate the sentence, I have a dog. And what it does is it says, okay, I know how to translate dog because I've seen that before. I know how to translate I have a cat because I've seen that before. So maybe there's a way I can break that up and recombine it to translate the sentence I have a dog, even though it hasn't actually seen that exact sentence before. That's the very, very, very basic premise of how it works. Now, if we look at machine translation on the right, we look at the image on the right, it gives you a little bit more kind of a flavor of how the human would think about it and how we build more context into that process. So for example, the word, if it looks at lots of examples, it's going to see, for example, in Spanish, the word banco will either translate as bank or bench. However, if the word banco is followed by certain prepositions or other words, it's always bank as opposed to bench. So it doesn't just look at each word in isolation, it looks at each word in the context that it has occurred and uses that to help kind of get through different ambiguities. And so you'll hear a lot about training and models and data. And so let's look at exactly what we mean when we say data, because data is the gold here. Data is key to any AI, any machine learning. You need to have data. And so what data is in machine translation is what I said before. It's previous examples of translated documents. So what you see there, for example, is a Harry Potter book that's in English and in Chinese. That's training data. You can use that to train machine translation. So it's key that we have this data, but it needs to have some characteristics, which we see here. So the first thing, there needs to be enough of it. It needs to be of sufficient size, right? The idea here being, if you haven't seen a particular word in your training data, the machine translation won't be able to translate it. So you need to have a lot of data. And when we say a lot, we mean a lot. We mean hundreds of millions of words of previous translations. Now, a counter to that would be the weather forecast example that I mentioned before. There, you don't need a lot of words because there's only so many words you can describe the weather, and maybe 200 or so. But if you want to be able to translate anything that you throw at it, it's got to have seen a lot. The second point there, it needs to be representative of what you're trying to translate. So there's actually different types of machine translation. So I mentioned in Iconic, we build machine translation for legal or for pharmaceutical, whereas you have the likes of Google Translate, which are general, right? So if we train a machine translation system on all the Harry Potter books, it's not going to be able to translate a contract very well because it won't have seen the language and the style of data that you'll have seen in a contract. If you want the machine translation to be able to handle anything that you throw at it, you have to train it on as broad a set of data as you can. One of the things that we do, for example, is focus on specific sectors. So we might train a machine translation system for contracts. So what we want to do is actually omit a lot of data that isn't to do with contracts because that might skew things, and try to train it on as much relevant data as possible. There's a technical term there that we use called in-domain data, and that's what you need. And then the last point there, it actually has to be good quality data as well. The translations have to be good translations. They can't have noise in them, like misspellings or OCR errors. And a lot of what we mean there is a lot of data is scraped from the web, and some of it might have already been machine translated. So the last thing you want to do is train the machine translation on machine translation. It's like I can't think of a good analogy for that, but it's not something that you want to do. So that's effectively the very core. You have data, so whether it's statistical or neural or whatever, you have data and you train machine translation systems on it. Now, that sounds easy, but the algorithms struggle, and we're constantly looking at new algorithms to work out how to crack the nut. So I want to explain a little bit about why machine translation is hard, because image recognition, search, things like that, they're pretty good, but why is machine translation so hard? And the real answer is language. Languages are alive. Words and phrases can have more than one meaning. They can have many meanings. They can be on their own ambiguous or structurally ambiguous. So for example, the word bank can be a financial institution, a noun. It can be the bank of a river, a noun. It can be a verb, to bank your car. Dive can describe the verb to jump into water, to fall down, or it can be a dive bar. You can have sentences like, I saw the man with the telescope. So did I see the man through the telescope, or did I see a man who was holding a telescope? We don't know. That sentence is totally ambiguous, and that can have an impact on how you would translate the sentence. So again, you need a little bit more context. If that context isn't available, you got to take your best guess. People use language creatively. There's new words cropping up all the time, and like I said, if the machine translation system hasn't seen a word in its training data, it won't know how to translate it. So that's a reason why they have to kind of constantly evolve as well. There's simply more than one way to say the same thing. New York, the Big Apple, NYC, NY, they're all the same way. They're all different ways of saying the same thing. So again, the machine translation has to know all of the different variants, and that includes, I did not and I didn't. Right? They're contractions of the same thing, but it has to have seen and learned about that. But the last and kind of biggest reason why it's so hard is just languages are different than each other. You want to translate between two languages, they're both different. So one example here. So I'm from Ireland. I speak the Irish language, and the structure of the Irish language is totally different than the structure of the English language. So for the English sentence, I am hungry, the Irish translation of that is tá ucras orm, which word for word literal translation means is hunger on me. So if you just do a word for word or look up the words in a dictionary and translate them, you're not gonna get a very effective translation. So there's a lot more background, context, subtext that we have to learn about the grammar of a language. And that's why it's hard, because that's different for all languages. So broadly speaking, with machine translation, historically, maybe less so today, a rule of thumb is that for any pair of languages that you want to translate between, the closer they are in terms of the order of the words, the easier they're going to be for machine translation. Doesn't always hold, but it's a good rule of thumb. So let me give a couple of examples of how machine translation can be progressively harder depending on the languages that we're looking at. So with English Spanish here, we can see that for this sentence, the man studies machine translation. It's broadly almost word for word translation, with the exception of machine translation, where you flip the noun and adjective around. And that's something that happens commonly between English and Romance languages. So again, the machine has to learn which pairs of words actually do that. Another example here from English French, which will also apply to English Spanish, Italian, Portuguese, for example, is there are different concepts that we have to account for, like number and gender. So if we're translating the word the from English into French, in order to know what the correct translation is, we need to know what the noun after the is. Because if it's house versus houses, singular versus plural, or house versus cheese, masculine versus feminine, it will have a different translation in French. It'll be la, les, les, depending on the context. If we're going the other way from French into English, we don't care about the context. All of those various options for the just get translated into the. So in that sense, it's actually a little bit easier to translate from French into English than it is from English into French, because we have to work out less. But these guys would be on the easier end of the spectrum. English German would be a step up in the difficulty level. And this example really dates when I first made this particular slide, just after Germany won the World Cup in 2014. So the English sentence, we like that Götze scored a goal in the final. The literal translation of that, if we look at it word for word from German, is we like that Götze a goal in the final scored has. Because in German, when you have a subordinate clause, the verb in that clause gets moved to the very end of the sentence. And that's hard for a machine translation to capture, because in that sentence, you know, where you actually put the word might be very far away from where it was in the original English sentence, because you know that could be even longer. We like that Götze scored a great goal in the last minutes of the final. So that's even longer, but the verb still goes at the end. So that, you know, the further away it is, it's called a long distance dependency, the harder things become. And then, you know, we take a step up again when we look, for example, at Asian languages. So this Chinese sentence that you see here translates in English to the farmer who grows fruit. But there are significant differences there. So the article, the word the, in English doesn't exist there in the Chinese sentence. So if we're translating from Chinese into English, we have to create that word effectively. If we're going from English into Chinese, we have to know to remove it. And also the tense of the verb is not explicit, it's implicit. So we have grow, which is the gerund, but we need to infer from the context whether it's grows, growing, grew, will grow. And again, that's an extra level of complexity that we need to learn, and we need to have seen in all of the different data sets to make sure that we capture those particular characteristics. So what I want to show you now is with this German example, how the evolution of machine translation from what I described as rules to statistics to neural has impacted on the quality of machine translation. So if we are doing rule-based machine translation with this sentence, what do we need? We need a linguist or two or three who are fluent in both German and English and who understand formally the grammar rules of these languages to write a specific set of rules that reflect the changes that you see here. So a rule that reflects that, for example, in English goes to a single word in German, and writing some rule that defines a subordinate clause in a sentence, identifies the verb there, and moves it to the final position. And that's just for one particular rule. There's going to be tens of thousands of rules, and that's just for German to English. If you want to do it for a different set of languages, you need a different set of linguists and a different set of rules. So that's why rule-based machine translation didn't scale very well and wasn't long for this world. So when we move to statistical, what essentially happens here is it does counting, right? So it's counted in its data set how many times the word final in English occurred in a sentence with finale in German. And it counts up the frequency of that, and then it translates this sentence in chunks of words. So it's going to translate "we like that," and then translate "Götze scored a goal" in the final. So it's going to do little windows of that to produce a translation based on the chunks of the words. And then there's like a separate machine learning model which tries to find should any of these words have been moved around. But again, things like this where you move the verb to the very end just cause problems for that. So with neural machine translation, the big difference here is what neural MT does is it looks at the whole sentence here in context. And what it does is it's going to translate word for word. So it's going to translate "we" into German. Then it's going to translate "like," but it's going to update the translation of "we" based on however it translated "like." Then it's going to translate "that," but it's going to do that based on how "we" and "like" were translated. So it keeps going back and forth over the whole sentence. So it's taking in the entire context the way a human would. You're not going to just ignore the start of the sentence to translate the end and vice versa. It takes in the whole context and it goes back and forth over it to produce the final translation. And that's why we get better, more fluent translations with neural MT. But like I said, that requires immense compute power to be able to hold all of that information in the memory of the computer to calculate that at the same time. And that just wasn't feasible kind of 5-10 years ago. So this is anecdotal, but I want to give you an example of kind of how neural has improved on statistical. So this is a real, and as I said, I know it's an anecdote, but this is a real example from when we updated a statistical machine translation system of ours from Russian to English to neural. So this was the English translation of the Russian using a statistical system. It said, "We checked, unfortunately, to organize video conference will not possible for technical reasons." Now we know what they're trying to say there. Couldn't do a video conference because there was technical problems. But the translation is awkward. And that's the way machine translation was a lot. It was awkward and sometimes it made no sense. That same sentence translated with a neural machine translation system, so just a different algorithm trained on the exact same set of data, gave us the translation. Unfortunately, we have clarified that it will not be possible to organize a video conference for technical reasons. So you can see there's a massive improvement there in the fluency of the translation. It's still, you can still understand the meaning in the statistical one, but this is reflective of a general improvement across different languages, and Russian to English is pretty hard of what we are achieving in this shift from statistical to neural. That's not to say that we're done, but we're definitely going in the right direction. So a couple of take homes here, just conscious of the time as we wrap up. Neural machine translation is now the state of the art. There's nobody really doing statistical machine translation anymore. There might be a couple of companies who have some legacy systems still in production, but really speaking, neural machine translation is the state of the art, and it is the way forward. However, machine translation is only as good as the data that you use to train it. So if you use a bad machine translation system somewhere, there's a good, maybe it's an old statistical system, or maybe whoever built it didn't have very good training data. So again, you know, if we're focusing on translating Harry Potter books, there's no point in us training on contracts. If we want to translate, for example, in e-discovery, you're going to be translating a bit of everything. You're going to be doing a lot of emails, which will have slang. So when you're training your systems, you need to make sure that you have elements of slang in there, of real speech, of as opposed to kind of legalese, and that's part of the challenge here. I mentioned also that the languages involved, they used to be the biggest determiner of quality. 5 years ago, if you said, "Can you do English French?" we say, "No problem." If you said, "Can we do English German?" we'd say, "We'll give it a go." If you said, "Can we do English Korean?" we kind of wince a little bit. That's not really the case now. That's been smoothed out somewhat. However, if you're translating the same French document into English versus the Korean document, you're still probably going to get a slightly better translation from the French document. But today what we see is that the biggest influencing factor on the quality of translations is the quality of the input document. It's garbage in, garbage out. So when we see our clients, for example, using our e-discovery technology, maybe 5% of the cases, some of the translations aren't legible, or it's hard to work out what's going on. And generally, if you trace it back, it's because it was a scanned PDF, or there was bad OCR, or there was something nasty going on in there. And yes, you can still get some very weird translations occasionally. And again, you can trace that back to it being something unexpected in the input that the machine translation system hadn't seen in its training data. And that's one of the quirks of neural MT with a statistical system. If it hadn't seen something, if you got some new input, it would just kind of go, no idea, and it would just like spit it back out again. Whereas what neural does, it tries to be clever and it tries to produce something, and sometimes that can be a little bit haywire. So if you ever see something weird in a translation, that's probably what happened. But overall, things are trending very positively. We really see questions around if the quality is going to be good enough going away, and it's more about building scalable, secure products that can be used in different kinds of ways. So with that, I'm going to pause here. This is actually the thank you slide, which is a very high-level overview of how neural machine translation works. But I'm going to stop here in the last few minutes that we have and hand back over to Stephen to see if there are any questions. Mute.
Secondary mute button. Thank you. Yeah, there's a few questions that have come in, and I'll try and do them in context. We might not get to them all, and some of them we might pick up in our Q&A session later. But I think the first one, and most relevant to what you last said, is that do you see a time when neural machine translation is near perfect?
Perfect is in the eye of the beholder. It can be perfect. I've seen neural machine translations that are absolutely perfect. A person wouldn't produce a better translation, but it's consistency, right? It's not always going to be able to do that. So we rather than thinking about it like that, we rather think about, you know, the actual use case and where is it more appropriate to use machine translation versus a person. E-discovery, you've got 20,000 Russian documents. You're not going to ever have a person sit down and, you know, translate all of those documents. You're going to use a machine. It might not be perfect in all cases, but it's definitely going to absolutely do a sufficient job for you. So it's going to constantly get better, but that oracle of will it ever be 100% perfect all of the time? Humans aren't even 100% perfect all of the time. There are a lot of bad translators out there. So yeah, I would say it's just going to keep on getting better, but you know, there will always be a place for the humans and the machines to coexist.
Yeah, that was actually one of the other questions that came in, and looking at the source, I kind of understand why. There was a question that basically I think was trying to get to the point was at what point will neural machine translation get rid of physical translators? And I think you've answered that. They both have a place very much in what we do or what is done widely in the marketplace. There was a question also about training data. What do you use typically as training data? Obviously, there was a need to acquire a lot of data. This question is quite technical, but I'm trying to simplify it. Typically, what do we use for training data?
I'm not going to give any of our secrets away, but for example, there is freely available training data on the web. For example, one of the most common things is the European parliamentary proceedings exist in all of the official European languages. So you can go online to europarl.eu and download, since the 70s, all of the transcriptions of European parliamentary proceedings and legislation in English and French and German and Spanish, etc., etc. It's all there. You can buy data. You can create your own data. Your clients can provide you data. So for any given product or any given machine translation system that we will have sourced data from a variety of different locations, and that can often be the difference. The main difference between one machine translation system and another is where they've got their data from. You might often see two providers have very similar machine translations sometimes when you look at them, and maybe they had both used very, very similar resources. So yeah, there's a mixture of sources to where we get our data.
Right. Well, we've reached the end of our allotted time. There were a few questions that were hanging over, and I'm going to push those into the live Q&A later on today. But for all, from John and myself, we'd like to thank you, everybody, for your time. If you've got any questions of us, please come to us via myself. You've got my email address down below there on the slide. Thanks ever so much for attending. Hope you got something out of it. And if you think you need a little bit more, please ask. We're here. And hopefully we'll see you at the live Q&A later on this afternoon. In the meantime, from John and myself, thanks very much, folks. Go safe.
Thank you. Bye-bye.
Bye.